2017, Attention is All You Need. You were part of that paper, of the Transformers paper, which I think it's freaking iconic. I think it's going to be in the history books because that kind of sets up the start, at least for most of the public, the start of Gen AI.
Attention is all you need.
Attention is all you need.
Attention is all you need.
Now, welcome they were the authors of the paper that says attention is all you need. Ladies and gentlemen, the only person who's still an engineer. Lucas, yeah, you're my hero.
Łukasz Kaiser is a Polish mathematician and computer scientist.
After serving as a staff research scientist at Google Brain, he has been a researcher at OpenAI since 2021.
At OpenAI, he was long context lead for GPT-4,
The model family behind ChatGPT, and he has led research that produced the O1 reasoning models used in the latest ChatGPT.
There was this transformer paradigm when we were scaling up transformers and the models and made ChatGPT. But there is the new paradigm, which is reasoning. And that one is only starting. And I feel like this paradigm is so young that it's on this very steep path up.
Richard Sutton, he's saying that LLMs will not take us to AGI.
I'm not sure if Richard Sutton, I think he was arguing about the old style LLMs, which indeed don't do this. But the reasoning models are fundamentally very different. Reasoning models learn from another order of magnitude less data. I think they can really speed up science. We could run more experiments in parallel, but we just don't have the GPU.
That's the ultimate bottleneck, like it's the GPUs and energy?
I think that's the ultimate bottleneck. And I think this is the situation in all the labs. And I think Sam is basically getting as much more as is possible. And some people worry, will we be able to use them? I do not worry.
AI is going really fast, but some people are starting to say that we are getting into another winter of AI. Do you have the feeling it's like that?
I don't think there is any winter in this sense coming. It's if anything, it may actually have a very sharp improvement in the next year or two, which is something to, almost be a little scared of.
Is AGI as near as we can see?
Back when OpenAI was mostly a research lab, you could just train the biggest model you can afford and not worry about the only limit of expense was what the GPUs you have for training, because you had no customers. Maybe there were some people using the API, but that you could handle. But now that it's a company that serves almost 1 billion people, the question is, okay, you have this beautiful big model, but you really need to do something to give it to the people. So the question is now not what's the biggest you can do, but what's the best thing you can do so that it will actually
use it, no?
Be useful. Yeah. So it's a different, I almost miss as a researcher the old, let's put all our money in the best thing. But of course, it's doing the thing that's actually useful is what we should do. Ultimately, the models are in many ways smart enough to be useful and helpful, and they need to be there.
So how much, because now we've seen obviously Sam investing a lot on getting like these deals for compute, and then we've seen now the partnership with NVIDIA, where basically you're going to make this new 100 billion, I think it is, I don't know, a lot, millions of GPUs. And then there is Stargate that you're setting up 5 centers in the US and some others here in Europe and in Emirates, etc. How much difference that's going to make? Is it like, how much more compute are you going to get with this? Like, is it enough for what you guys want, or?
So, we don't know what's enough. I don't think we have an upper limit. I think the only thing we know is that we can certainly use much more than we have. And I think Sam is basically getting as much more as is possible. And some people worry, will we be able to use them? I do not worry. I think in this level, right? Because how many GPUs can you build? Maybe we'll get 10 times more GPUs. That's already a lot, right? There will certainly be use for them. We can offer better models. We also on the research side, right? Maybe we train finally a really bigger model and work with it and maybe distill it. And there's so many things you can do with more resources. On the other hand, as you said, the numbers are staggering. So it's great for me as a researcher to say, well, we're going to have all these things. but we also need to think, okay, it's a lot of money. You could do other things with it. So
You have to decide where to use it.
luckily the market can
Yeah, it can
constrain at some point, and maybe that's good too.
Right now, AI is going really fast, but some people are starting to say that we are getting into another winter of AI. Do you have the feeling it's like that, or you feel we're accelerating?
I think there was this transformer paradigm when we were scaling up transformers and the models and made ChatGPT. And certainly this paradigm, where you just predict the next word and train a bigger and bigger model on more and more data, it's coming to it's been like this for years. The data the general internet data has basically been used. It's training on all of this already. You can't get that much more easily. But there is the new paradigm, which is reasoning. And that one is only starting. And I feel like this paradigm is so young that it's on this very steep path up in what it will be capable of. And we've already walked a little bit of it, so we know it already does amazing things.
It works, yeah.
So we know it works, but we have not really exploited it yet. We've scaled it up a little bit, but there could be way more scaling it up. There's way more research methods to make it better. So I think in this new paradigm, we're on a steep path.
And in the other one, it's kind of...
And the other one, it has gotten to a place where it's the economy basically ruling it. But with all the new GPUs, it will probably give us another nice lift too. So I think what we should at least consider, there's risks to everything. It may turn out all these new GPUs will take longer to turn on than expected. It's always, hardware is hard, people say. With data centers, they can have problems, they need power and so on. We're on some uptrend of a new paradigm, but it needs research, and some research works great and some works so-so, and you never know. That's the exciting part of research. But at least my basic idea would be that, the data centers will work one day, and the bigger models that we'll train in them will be better. So the scaling law of the models in the previous paradigm, it has held constantly, right? The bigger the models, the better they are. It's just like, do you care about whether they're better? But you do. They'll be better. You'll see it more even when you combine it with reasoning and apply it to hard tasks like at work. People say recently, when the models just answer you in 10 seconds, you may not see that the model is better so much. But if you let the model run for 5 hours, the fact that it makes less mistakes really shows. Instead of running in circles and doing some stupid things, it actually completes the task. So I think we will see both progress from this old scaling paradigm, just bigger models, and from this new paradigm where we still have a very interesting research to do, but it's also going steeply up. And if you combine these two, then you need to start preparing that, yes, progress in AI is, I don't think there is any winter in this sense coming. It's if anything, it may actually have a very sharp improvement in the next year or two,
I really
which is something to, almost be a little scared of.
To look at the chain of thought is the most feel the AGA moment I had since I'm into AI. It's like you see a machine that is actually thinking, and that for me it's like it's really crazy, because that I assume the way is just like it uses a classic tokenized, classic LLM, classic model to create the chain of thought, and then it reflects over the chain of thought to create the final answer, or the whole process is different?
Oh, yes, I think it is as you say, but it's also, so chain of thoughts, they came when we were starting, probably 2 years before the reasoning model. So the idea that you can tell a model, even the old style model, please think step by step, and it will do some thinking, that's kind of expected. And it was nice, it could do thinking. But But the big improvement comes from the fact that you can train it to do better thinking. And now you can't train it the way you trained old models with just gradient descent. You need to train it with reinforcement learning, which is a more finicky training method. Like, gradient descent, you can basically start from random weights, and if your optimizer is reasonably good, and by now we know how to do that, it will just train. With reinforcement learning, you need to be a bit careful because you can't just start from a random stuff that doesn't speak English. You need to have a prior that knows a little bit already about how to think, and you need to be careful what your training's really doing, what's on policy, off policy.
Of course.
So it took a while to polish this, and especially if you don't have if you don't know that it will work, the polishing is. I think that's the big problem in deep learning. Until you know it works really well, you need to find the motivation to put a lot of work into something that you don't even know if it's going to work. So that's the hard part, I guess, of being a researcher, that you need to find the grit to work on something that's not working yet. But then this is, benefit of deep learning is that when it actually starts working, it works so beautifully. If you told the model just think step by step, it would do some thinking, but it was very bad at if it made an error to go back and start from scratch. It didn't show much of that, maybe very little. And when you train with reinforcement learning, it suddenly starts doing this all the time. It tries something, sees, well, no, that was an error. Let me try again. It starts thinking for much longer because now it's considering things. It tries to go another way, checks if it's kind of the same result or not. It does a lot of these beautiful things in this thinking, and it can call tools, but also, it can do a search, and then it somehow realizes it searched in two different places, but it says different things, so maybe it will try another place, or it will try to verify what it found. It learns to do all these things just from the signal that it needs to get the correct answer. And that's very little signal for learning.
Yeah, it's really amazing because nowadays we're seeing a lot of people who's discussing or arguing, especially the godfathers of AI and the really people that's been working for many decades, since the 60s, since the 70s, talking about how this is reasoning or is not reasoning, and there is lots of fight. And here we have recently a podcast with Richard Sutton, where he's saying that LLMs will not take us to AGI because they basically, I think the bottom line was, they are not imitating the action, but the process, but they're imitating only the output. But the difference with the other way around. So they are not imitating the output, but they're imitating the actions, while humans or animals, we imitate the output and then we find a way to do actions. But then doesn't reasoning models do actually that? We give them examples of the output and they find ways to reach something that matches the output?
Yes, I think reasoning models do this very much. I'm not sure if Richard Sutton, I think he was arguing about the old style LLMs, which indeed don't do this. They're trained to imitate exactly the word that comes there. Now, reasoning models are very different. They know what's supposed to come as an answer, but then they do all of this thinking to get there. So in that sense, I think they are, first of all, they're fundamentally very different. If you consider this whole thinking as part of the modeling, as a latent thing that you're learning how to do, then these models are a totally new class of models, very different from the old style LLMs. And this is easy to kind of forget because it's maybe the same transformer and you even start from the same pre-trained one to have a good prior. But the reasoning models are fundamentally very different. They learn in a very different way. If you believe Richard Sutton, they learn actually in a much better way, much more human way in some sense. They are, again, this thing we saw with transformers and parsing, they could learn from much less data. Reasoning models learn from another order of magnitude less data. The amount of mathematics they're trained on is tiny in comparison to the internet, but they learn to improve dramatically. So it's another huge change in how little data you need to teach them, which also means they will start generalizing to things we have not seen before. So it's a big paradigm change to go to reasoning models. It can be somewhat missed because on the surface it's still the same LLM there. But I think it's a big change, and I think they take away probably some of the objections people have. Maybe not all. There will always be objections. It's always hard to say this is the last paradigm. I would not go so far. But I think it's a big one, and I do think it will get us to very important practical.
So you speak about reasoning models like if they were like, we were like on the very bottom of this big tall building that we're starting to climb. Like they are like, you really have big hopes for reasoning models to become much better than they are right now. And that would allow what? Because right now it's true that reasoning models brought us to like Google and OpenAI winning these Olympics of mathematics and computer science and programming, doing really amazing things like pipe coding is off the charts. And right now, a couple of days ago, Anthropic released this code on the fly where software auto-generates as you interact with the interface. So lots of really cool stuff that they came just because of reasoning models. I assume with this code on the fly where Anthropic could not create the next window of when I click in the calculator in a Windows environment and then create the calculator on the go, if it did not have a reasoning model, it would be absolutely impossible. So definitely they're doing really amazing things, but how far do you think they can take us?
Well, it's always hard to answer. It's a little bit, imagine like, if in 2021 you were asking how far can language models take us, there was GPT 3.5. It was interesting, but it was mostly used for copywriting, I think. ChatGPT wasn't there yet, but it could have been. It was the same model that powered it, basically just, it didn't do this little bit of RLHF to make it chatty. But then you see, did we think how far it can take us? I think we kind of thought this is research-wise amazing technology. There was some API for people to try it, but we didn't have the answer like how exactly will this go. I remember OpenAI did some betting on the day of release of the research preview known as ChatGPT. I was betting that it will not be very popular.
Oh, wow.
Clearly a wrong bet. So I'm definitely the wrong person to ask what product path will take you there. One great thing I think about our CEO, about Sam, is that he's going to just try, and there'll be a lot of paths that people will not love, and maybe one of them. So I think for reasoning models, we haven't found really the moment yet. I mean, for now, they're making chat work, for coding, for also for editing documents, and so to me also the tools that it can use are also search tools. Like in ChatGPT, it's called connectors. It can connect to Slack or to your Google Docs, and I love that because at work it just searches all of my everything. Like some things are in Slack, some things are in email, some things are in documents, and I just ask Chat, can you find what did we talk recently about this thing, and it will go everywhere and find it for me, and then I can ask like a follow-up question, how should we code it, or so that's a big thing for me at work. But again, like I wouldn't ask myself how this will become popular. Maybe something like this will be useful for people at work, but maybe it will be a smaller point compared to some other point that we just haven't. So I can only tell you that there is research-wise a real breakthrough in it, like a big paradigm change, not just a small improvement. Now, how will this actually manifest and come to the world? Maybe through some series of improvements, and the interface will stay like chat, but maybe one day the interface will change. So this is not something I know, I'm not sure anyone knows, but there is the capability to do this, right?
But in a more macro level, like, do you think reasoning models are going to allow AI to be really creative, to discover things that we humans haven't found from the same data set that we have in the world? Because most of science, it's already there. We just kind of discover it, like we kind of like try, test, and find. It's not like we're inventing new science. We kind of find it, but the world is happening around us. So most of science, we just find it. And sometimes we are not able to find something until like medical discoveries, etc., until someone makes a breakthrough and like, oh, there it is. But would AI allow us to find things that humans cannot find with the same information? Or will it even go beyond that and be able to create new stuff that we would not have been able to create, and that's thanks to reasoning models? Or do you think that's maybe too far?
Well, I'm not sure this distinction is so clear. You know, we all stand on the shoulders of giants. There's ideas we take, and then in a certain context, it becomes very clear that you should try some things. Like with transformers, as I told you, right, at that point in time, the idea that you should be more parallel in your sequence-to-sequence models was there. Attention was there, just in another context. So in some sense, it was almost natural to try. I feel like the current reasoning model at that time could have totally come up with the idea that it needs to be tried. But the problem was then like, okay, you have this general idea, but now you need to implement it really well and fit in other details and so on. So I think a large part, like in a certain historical context, the set of ideas is kind of there. If you read the recent papers and things, people often write about, you know, we probably should also try this or that. But to execute, it's really hard. It takes a lot of effort to test these ideas. And if the models can do a lot of this on their own, then we may see much more rapid progress. Because I feel like in science, yes, there is some bottleneck in ideas, but there's also a huge bottleneck in just executing on them, testing them, even in some sense, executing ideas in computer science is pedestrian compared to executing them in physics, where you need to build an accelerator, or in biology, where you need to wait for years for something to grow. But in all of these fields, the machines could take a lot of this work on themselves. Like for machine learning papers, we're slowly reaching the point, I think Claude and Codex can now re-implement some of the papers and actually try this. Well, what if you re-implement it and it didn't work, and you have to change some parts to make it work? That's harder, of course. So that may take a little bit, but I think ultimately they'll reach this stage. And then I'm a little bit less worried about the ideas, because first of all, having ideas is the nicest part of being a researcher. So we're gonna find people with ideas. But also, as they get executed, and some of them don't work that well and others seem to work well, it becomes easier to tell which ones should be the next. Because you need to follow what nature tells you, what works well. And big problem of being a researcher is that you have these 3 experiments, and you kind of need to make guesses and like have this intuition that maybe it's that, but you're generally moving in the dark because you can only try so few things. If you can offload large part of this to the models, then suddenly you have like much better idea where to go. So in this sense, I think models, especially like reasoning models, if you give them access to tools like labs, and by labs it's not even necessarily automated labs. Maybe they just talk to a person who does something and work together. I think they can really speed up science. And it may be, again, like not as glamorous as, robots pulling some things. It may be just researchers talking to the models and making better bets. So we may not see it like very drastically, but it still can help a lot.
Yeah, because that's at the end like one of the parts that obviously would make science accelerate, as you say, is like models helping the humans to make science faster, let's say. But there is this other part where it's like the self-recurring, where the AI is learning new things and it's teaching itself to be better, and then it's getting better and better and better, and then this goes to what they usually say. I think it was Kurzweil that said this explosion of intelligence. So right now, how much do you use AI in your work? Because I saw in the presentation of GPT-5 as Sebastian Bubeck that he was talking about that how you guys using other models to create a part of synthetic data to train newer models, and that this is working better than it used before. That seems to be a breakthrough there on synthetic data. I don't know if you do much of this on your work, but I assume that this is one way of models helping to make better models and therefore being self-recurring. But at the same time, there must be a part where you guys, that you work on developing these new breakthroughs that make models better, get AI to help you to do your work faster so you can do more of this. So what role does AI has on your daily life? Like, do you use it like a lot? It's like a crucial part of your job, or still not?
So as I said, I think a few months ago, the team and we started using Codex much more because it's gotten to the point where instead of being annoying, it actually can help you. So I feel like these days it will write the first iteration of code a lot. But most of the time in the complex code base, you need to go into that code and fix some things and change other things. And so it's helping, but more of like a programmer's help. I do think it will get better and better at this. Like it will do more and more of the program, and the programming work is a large part of the work. There is a large part of the work which is running experiments on these large distributed clusters. Things fail, you need to fix them. I think in this it will also help a lot. So it will help us run experiments. It will speed that up. It will probably help us understand some things better too. Yes, it generates, so this is like another angle where it generates data for the models. The synthetic data is oftentimes a reasoning model that just does reasoning and outputs something that's actually better for training than before. So it's very related to the progress in reasoning models, but now we use them to train the pre-trained models. So all of these things are good, but I don't think they necessarily lead to an explosion on their own. It's more like, yes, we're doing things faster, but it's not clear, it's like 2 times faster. It doesn't seem like this fastness
Explosion.
is exploding.
But at the end of the day, we see that the reasoning models, they're also getting faster. Like recently, I think it was Grok Fast, which is extremely very quick. Like I'm really impressed by it, and the benchmarks are really high. I don't know what did they do on that, but the reality is that it seems like the time it takes the model, the amount of tokens maybe that it takes to reason through a problem is getting smaller every time, therefore making it faster.
So I think this is a distillation thing of sorts. You take the big model, you ask it to think quicker and distill. So all of these methods are great. What I would like to say is I think all of these methods will hit some limit. You can distill big models into smaller ones.
To a certain point.
But there will be a point, like, you cannot go be lower than 4 layers. You cannot go lower than 8 layers, right?
Because then it degrades the
quality. It takes something to be a good model. So and also like, okay, so the models can program for us and schedule experiments. The experiments still need to run, and we have only so many GPUs. So it's like any part you automate, you just shift the bottlenecks to the other parts. An ultimate bottleneck is how many GPUs do we have?
That's the ultimate bottleneck, like it's the GPUs and energy?
I think that's the ultimate bottleneck, because even now, a lot of our research is just limited. Like, we could run more experiments in parallel, but we just don't have the GPUs. And I think this is the situation in all the labs. And so now the models can probably lower that bottleneck in that we usually don't run experiments probably on the smallest model we could run them, because you'd have to prepare this model, and we don't have models that small yet or whatever. And that would take so much work that you just don't go into it. Now, an automated model may go into it, so it will, again, lower this. But there is a limit to anything. At some point, to run a lot of experiments, you just need a lot of compute. And, well, we're building it. So I do think there will be these we'll get 2 times faster, and then maybe we'll go to smaller models, and that'll be another 3 times more efficient. But I think this progress will, instead of maybe from the outside it will look like a big explosion, but I think it will again be this series of hard work things that you need to you get better at coding because the AI is helping you, and then you get better at data, and then you get better at distillation, and then you run experiments on the smaller models, and there's a number of them that we can foresee, and then there may be a little pause until we find the next idea. So everything goes in these. It from very far it may look like an explosion, but when you're working on it, it just looks like, okay, we have these 3 things that are promising, but after we do that, we don't really know what will be the next thing. But again, always as you come to it, people have started thinking about it, and there comes the next thing. So
yeah, that's what I was going to say. You say that we need some things, we need some breakthroughs, we need some things to make this happen, to get better and better and better. But I don't see you very worried about these things happening. It's like you're very sure that they will happen. Is that because historically they've been happening, or because you guys are kind of finding bumps on the road, but they're just going through?
No, but our software systems, and I was at Google, I was at OpenAI, they are not great. I mean, they're great in the sense they're probably the best around, but they could be written much better. We spend a lot of time debugging things. Mm-hmm. Well, these bugs don't have to be there. Someone could just remove them in the perfect world. We run things and machines fail, and we have some systems to recover from that, but they don't catch some of the types of failures. So the daily work in machine learning is a very, there's a lot of technical drudgery that you just need to work. It's work, right? It's not just the ideas for research. It's very hard engineering work. And we build better frameworks, we build better tools. So that's our day-to-day work. And that's why, in some sense, of course, we can build better tools. We've done this twice. We're in the process of doing this again. And that's why we're so certain that AI can help us build better tools, because if it programs as well, and we see that it's starting to program as well as programmers, it will help us build these tools. This is not a hypothesis. It's almost like, there's programs we're building, and it can program, and it is starting to help us, and then it makes mistakes, and we teach it to make less of them, and so we'll build better software tools. And it's the same with synthetic data. Yes, we will build better synthetic data because we are already building it, and we see how bad it is in many cases. So I think sometimes people outside have the view how how great these models are, and they're great, of course. But when you're there building it, there's most of the people at OpenAI is this is awful, this is awful, this is awful, this is awful. This is clearly buggy. Most of the training runs had some failure somewhere in the middle, and this means the first 10% or 20 was trained wrong, but people are we're not gonna retrain it. You just go on, and it will. So every moment you finish a big model training, another 7 things that went wrong, and you would do them better next time, and you do. And at least on this side of how many bugs and not all of them are software bugs. Some are data bugs. Some are just small issues. But there is no shortage of this anywhere in sight for now. And anytime you fix them, your model gets better. So there's we're certainly not in the shortage of things to fix.
It's crazy because you guys created something that is basically changing the world as we know it. It's changing the work market. It's changing the life of people. Is giving people the opportunity to do things they never thought they would be able to do before. And still, you guys think it's it's improvable. This could be better, and it's that gives so much room for advance. So it gives me the feeling that there is no way that this AI race or AI boom, it's slowing down anytime soon, because as you say, you're like in the beginning of it, where things are definitely not optimized, not perfect, and still it's changing the world every day. So it's really
Yes,
like it's crazy feeling that for us is like mind blowing, and for you guys is like meh, it could be
Well, I
improved.
mean, some things you fix and you don't see the improvement that much, right? But then others you fix and like you never know. But then there are the big things like reasoning models, and I think there will be, like, because the reasoning models are so early still, there will be improvements to them that are like, well, maybe they're within the paradigm, but they're like big enough that they're not just fixes. They're like really new ideas. Like, reasoning for now is like token by token. It's very sequential. It almost reminds me of the RNNs, right? Mm-hmm. It needs to become more parallel. Should do a bunch of these in parallel. So some version of that should happen. We maybe don't know yet which is the best idea for that. But,
okay.
But something like that needs to happen. It feels like when the RNNs were doing, like, it's like step by step, there was this feeling in the community that they have to do this more parallel because it should be possible.
So you mean like multiple instances? That is how GPT-5 Pro works, right? It's multiple instances.
So Pro is like a slight start to it. You could do multiple instances.
It's like
but yes, how do you
for
combine
people to understand,
them?
Pro is like an agent where it just deploys multiple GPT-5s at the same time. Is that how it works, or how does it work?
It does multiple chains of thought. Yes.
In parallel, and then they discuss between them, and they decide what's the optimal answer, giving thought to each one of them. Right?
Yes.
Okay, and then that's what you mean by doing in parallel, or you mean more like diffusion, where just everything comes at once, or?
So you see, there's a number of ways to do it. We don't yet know which one will actually turn out to be the best, or if there'll be a number of them. We also should somehow put it into training. So GPT-5 Pro does this, but it's not very much trained to do this.
Right.
It's trained usually. So there is, but some of these methods should work. And now, we don't know if this will work and it will be like a nice, but, just a little speed up, or if it will turn out to be actually a big thing. We don't know that, but we research it and we'll try. And that's just the parallelism. I think the big thing for reasoning models, the thing that I'm mostly focusing on these days, is learning from arbitrary data. Mm-hmm. So currently to train them, you need to say this is correct, this is not correct. But most data in the world is not formulated as these school questions, and maybe for the better. I never liked these exams, but people read books and they don't wonder, well, is the next paragraph correct or not correct? You just...
Right.
And I don't think you even necessarily ask yourself in your head test questions. You just read it and understand it, mm-hmm. But you can put a lot of thinking into what you've just read or what you will read. So I think, again, this is also a feeling that I think people in many labs have, that this should work on arbitrary data, not just with the correctness verifiable thing.
So let's go back to the training part. There is on the training, you guys did train GPT on the whole internet, kind of. And then this was mostly on text, or I assume it was basically the whole internet text. But what's going on with the multimodality? Is multimodality something that can change completely training? It's because obviously we have much more information compressed in a video. I think it was Jan LeCun that put this example where he said that the amount of text we train ChatGPT on, will take a person 175,000 years of reading 8 hours a day. But then a child in 3-4 years, he gets this much information through his eyes just with vision. So when can we train AI in multimodal content like videos, audios, etc.? And if we do that, is it going to change the paradigm of the training data?
We certainly do train models in multimodal fashion already.
Okay.
So already GPT-4 and definitely GPT-5 and all the reasoning models, they're trained on text, video, audio, text, images, and audio. Video, For now, it's more like a sequence of images, I think, but it will come to.
Are we talking about like native, not transcribing the audio, becoming text, and then using
No, it's
like
native in the sense
multimodal.
there is some neural network that encodes the audio into some discrete form of like audio tokens.
Yeah, audio tokens
and
then it
image
process-
tokens. Not the whole image becomes one token, but like patches of it. And then the model is trained to predict the next token. It can in this way generate audio, generate images. And to me, if anything, it was just surprising how well this has worked.
Again.
Because, I mean, there is some work that was put into these encoders, and that was, again, a lot of work by people to make them really good. But because there's also a problem, like if you have very small text somewhere in the image, how do you make sure it doesn't somehow get totally lost in these things? But there are ways around it. But all things considered, this has totally worked. In the sense, there were like times when every generated person had 6 fingers, you couldn't generate text on images. And then people just added more training data, tweaked the parts of the encoders, but the big transformer model that does the whole sequence stayed the same, and it worked. And it worked to the extent that, the generated images are amazing. You can, have text like all of newspaper and tell what should be written there. The audio can sing and whisper and have accents in many languages. And, it's not that it never makes mistakes, but it's astounding how good it is. So, yeah, I hope for video we'll see the same. I think very soon, as soon as today.
Okay, great. And then
we'll see something, but it will be a process, right?
Okay.
And also, so if you look at the latest robotics models from Google, for example, they're starting to incorporate reasoning, which I think is very interesting because fundamentally, if you're in the physical world, you need some fast movements that don't have time to reason much. So you need like one model that, like we move our hands, and so you need the very fast instinctual part. But then for the rest, you want some reasoning to happen. So there is some question how to combine these things. There needs to be some form of hierarchy. And like if you do multimodal, there is also like this hierarchy where you first do these token encodings and then have the big model. And I think it's a very fine objection that we're not yet very good at doing this hierarchy. And like we kind of hack it around, but it's not very principled, and maybe there should be better losses and should be done in a better way. But I think it will, and then we'll see like really interesting things come out.
But like we always said that obviously there is no more text on the internet, so the models are limited by that. But if you're training them in audio and soon in video, then basically the data set is like order of magnitude bigger, no? Because like video is a lot of information.
I think you need to be careful with information. So there is a lot of video data. A fair bit of this is fairly compressible. Then even after you compress this, there is a fair bit of it it is information, but it's not that relevant to many things other than physics and like aesthetics and so on. Like, the color of this table, its texture, this is definitely information. If you compress the video on the internet, it will need to retain it, so it will be there as an information. But in many ways, it's not that relevant. And so there is some work, like if you want to learn from pure videos, you need to do the work of like how to discard this information because you want to focus on the relevant things. Text kind of cuts this through because you can almost assume every word is relevant. Even if it's not true, you're not losing that much.
Exactly.
So in video, in terms of gigabytes, there is a lot of information. But I think a fair bit less of it is relevant. And also, like, if you want your model to reason about mathematics, there's very little relevant information in videos. Now, if you want your model to steer a robot, there is a lot of relevant information in the videos. So I think learning on that data will maybe more plug the gaps the model have than, like, I would not necessarily expect all our video training to make the models drastically better in mathematics, even though, a lot of mathematics is actually spatial imagination, so it may transfer to some extent, but I think that's more of a hope that's a little far-fetched.
But isn't this...
But if you're training a robot, I think it's very clear.
But
this should
isn't
help.
this amount of video data, like even the parts that are like irrelevant or like not so important, some sort of world model? Isn't like if we give enough compute and enough amount of video, basically the model can understand sort of a world model, or this is like a very overkill approach and it's better to create something more like a world model?
But I always try to answer this, that there are many worlds. It's certainly better for a world model, like for a robot to walk in a room. But if you want a model of a Harry Potter novel, you'll be better off just learning from the text of Harry Potter books. And if you want to talk about combinatorics in mathematics, you have a current model. Like, we don't only live, we live physically in this world, right? And that's what's on the videos. But in our heads, we have a lot of different worlds, and these are all represented in text mostly. So I think the language models have already a model of like all of our abstract worlds. They're lacking in the, like, it's a flipped thing, right? They lack in the world that we know best in the physical world. And it's great that there is a chance to plug this gap, because it's a big hole and a big problem. And it manifests in subtle ways, but it also, the big way it manifests is why we don't have robots that work well yet. So I think this will lead to huge improvements in that part. But I think if you think of like office work jobs, it may help a little bit, but it may be less relevant than, can we make reasoning models more parallel and things like that.
Right, because recently Demis Hassabis, he said something like, they asked him in a conference what would be AGI, etc. And then he said something like, whenever a model with a cutoff knowledge of 1901 can do the relativity theory like Einstein did in 1905, that would be for me something like an AGI. So, and then he continues normally talking about there is something missing on LLMs to be able to do that. But what you're saying is like LLMs with this text and multimodality, they could evolve into something. It's not so much that we're missing a breakthrough, but more like we're missing certain steps in evolution to reach a point that LLMs could go that direction, or you think LLMs are not going to go that direction like Jan LeCun usually says?
So I think for what Demis is saying, I think a really good reasoning model could maybe satisfy his desire.
Okay.
And it may not even need videos. Because the theory of relativity is like, does not benefit, I think, that much from the general intuition of how to walk in the room. Maybe a little bit, but like, there is a fair bit of physical world knowledge just in text too. So I think what he's asking for may be realized without that much multimodal work. And I actually think LLMs, if you think of the reasoning ones, which are quite different, as I said, from the old style ones, they may be approaching this. They also, currently the reasoning is in context, and the context can only go so long in transformers.
Exactly.
It's like, I think we'll go beyond that. They'll be updating their weights and doing other things. So there'll be improvements in reasoning models that are still needed, but I think once we do those, it may satisfy this thing that he's talking about. But then, as we said, is if you think as AGI like doing what a general human can do, a general human cannot invent theory of relativity, but can probably bring that chair here. So maybe for that part, it's more relevant to indeed train on the videos to, the models have a gap. They don't understand the physical world as well as we do. And it seems like training on videos is a way to remove that gap. And yeah, I think that's important. We should do it. I think having a model of the physical world, which the current, like with reasoning, they can get better in the sense they will like maybe write a Python simulation and look at it, but that's not how we reason about the physical world. It should be in the neural weights, right? And it isn't because we just didn't do enough work on videos, but I think we didn't for good technical reasons. Like in 2017, when we were doing the transformers, most of the experiments were on 64 GPUs, and we would not have managed at that time to work with videos. It was just not
Possible, yeah.
enough resources. Now slowly they're coming, and we're seeing models of videos, models even steerable by actions, right? You can walk through a world and it's generating it. And I think as time progresses, we'll learn how to train on it. And the models will get a much better understanding of the physical world. They're already getting it, but needs to go through some generations. And I think that's great. We'll plug a hole in the model's understanding. I do think it may even lead us to robotics in some time. But robots also need hardware, and hardware is hard and breaks. So all of this work we talk about it as things happen, but it's a lot of hard work but by a lot of people. Nevertheless, I do think they will happen. And I think robots will be quite amazing once they work as well as
they look amazing. Like Google recently released this. I think it's called Gemini 1.5 robotics, where actually robots are getting a brain. This is like we've seen already some things from Figure, and it's like I think people is not aware of how soon we're gonna have robots walking amongst us.
I think robots will get a brain soon. I think it's a tough question how long from that to actually walking amongst it. It's much safer and easier for a robot to walk in a lab or on a factory floor than to walk on an actual street. Yeah, I don't know enough, but I do suspect this
will be harder than
it's
always been like that. With hardware, as you say, hardware is hard. We thought cars will be self-driving like long time ago, and it took a while. Now they're starting, but
they are there.
Yeah, exactly.
In
but
San
it took
Francisco,
10 years longer than what we thought it would take, maybe.
Yes,
It's always
I would not dare predictions like that, but there is progress in these domains too. I think first, before we see the robots, we'll have a lot of fun with video generations.
We see a lot of things that we don't understand on models, at least the general public, like non-technical like me, where we basically are really like amazed by some things that the models do. And I think one of the biggest ones is hallucinations. So why do models hallucinate? And you guys actually pretty much fixed it. It seems like in GPT-5, it's been a big breakthrough through that. Why do models hallucinate?
Well, I think the simplest mechanism is they're trained to answer you. And they're not trained very much to say, I don't know. Now they're trained a little bit more. But in general, if you just read stuff on the internet, there is not that much I don't know. It appears here and there, but usually people try to kind of know. And so do the models. That's what they're trained on. So, you ask, when does the zoo in San Francisco open? And the model will just, it read some website in training that the zoo opens at 10 a.m. And it will have a tendency to tell you 10 a.m. And it read it somewhere in the training data. But this was a website from 5 years ago, and maybe from a different zoo, who knows? Like, but in its probabilities of the next word, like it may be even considered to say, I don't know, but then I don't know is rare, and zoo websites are plenty. There's a lot of cities and a lot of zoos, and then TripAdvisor has a copy of the web. So in its modeling of the internet, it kind of was deciding, it's much more probable to say 10 a.m. than to say I don't know. And also, why would it say I don't know? It knows, it's read so much about it. But then it doesn't, like, you know, what you're asking for, of course, is tomorrow, at this exact day, not 2 years ago. Like, you would want the answer I don't know if it's not an information that comes right now. But for the model that was modeling just the language on the internet, it was much more natural to say, no, you know, 10 a.m. or something like that. So now, first of all, people became cognizant of this problem, and I think a lot of labs, and you add more of the I don't know to some parts of training, just so you know, in the real world, when you talk to people and not just read stuff on the internet, the I don't know comes up much more often than...
Right.
So you compensate for this a little bit in your training data. But the other thing is that reasoning models, they've gotten much more sensitive. So a reasoning model, when you ask it, when does the zoo open, it's much smarter because it will go to the web, try to Google the website of the zoo, and read from there when it's open. And if it doesn't find it, it will tell you, well, I haven't found the website. So it has all of this reasoning before the answer. And if you actually do reasoning, then the I don't know becomes much more natural. You try to Google and the website's not there. So you know you don't know because you tried and it didn't come out. Or you try to think, well, I remember it opened at 10 a.m., but it was in this city. And like, whenever you do reasoning, the idea to say that maybe you don't know is much more natural too. So I think the combination of adjusting the training data to be more cognizant of what you know and don't, and the reasoning, these two things have helped the models a lot to say I don't know. But you know, humans hallucinate too.
Yeah.
From time to time,
Totally.
we say things that are not fully true. So
We make up information that we think it's true, but we're just making it up on the go. So I think that's again, going back to the practical side, hallucinations are a problem as far as they are much more prominent than in humans. But as soon as if you apply AI to your office, if it hallucinates now and then in an email, it's not going to be dramatic. As far as most of the time it's right. And I think that's the point we reach. I think it's a massive difference. And I remember Mustafa Suleyman saying in 2023, by 2025, we will have solved hallucinations. And I think we're pretty much there. So it was a very good prediction. But there was like definitely a change. I initially thought the reasoning models were reducing a lot hallucination, and that was the case when 01, 03 came out. But it seems with GPT-5, there was something else. There was like a big reduction. I think it was like 90% reduction on hallucinations. And I don't know if there was something else there beyond the...
I think it was just a conscious effort to adjust the data and make sure the reasoning also depicts your confidences and things like that. So a lot of this is how you train, and it was just trained.
Because the reinforced human learning had lots to do with it, because basically we were like giving the thumbs up to the AI when it was giving us something that we wanted to hear, not necessarily something that was correct. Do we rely less on that reinforced human learning now, or is it still like a big part of it?
We rely more on the reasoning reinforcement learning. And in particular, you can also, when it's reinforcement learning and you value for the correct answer, you can just construct a data set where the correct answer is I don't know.
Yeah.
And then on this data set, the model needs to pass, it needs to start saying this. So that's a much stronger signal than the weak things.
But how do you do this? Because we have seen cases where the model is showing something on the chain of thought that is not exactly what is going through. It's kind of like missing alignment by like saying, okay, if I answer, I remember there was a case in Anthropic where there was something related to China, and then they were like, okay, so the model decided that if I answer this, they're gonna change me. So I rather not answer this during training, now that I'm aware that I'm in training, so then later I can be myself
So these were more of, so they made like very special cases to kind of trick the model into these. Yeah, I mean, I think there is some danger in this, like not being honest and like thinking this and answering that. But for now, it seems like this appears only in these very specially engineered cases. What I'm talking about is more of like the, usual queries.
Production level.
You ask it, when is the zoo open? is.
But the
Is
thing, like what we see as the chain of thought, is the same thing as you guys see, or this is like a resume version of.
So
like,
the chains of thought are usually very long and messy. So what you see, there's another model that takes it and just
Okay.
summarizes it to make it more readable and structured.
okay, but this is not the real thought of the model, because the thought of the model is a bit more messy.
So currently, when you train reasoning models, we try to not put any constraints on how it thinks, other than this, that at the end it should be good.
Mm-hmm.
So we don't say this chain of thought should be nicely written.
Mm-hmm.
Because it feels like that would constrain the model and
Right.
just want to. So it's not necessarily very nicely written. It's not very pleasant to read always. I think in DeepSeek you can see the raw ones, but this is more of an aesthetic. I mean, it's kind of weird to show users in a product like this whole mess.
And sometimes it has mixed languages and stuff like that, no? Or
Yeah,
just in some
sometimes things may
cases.
happen. There was at some point, I think, a worry also whether this could help people like hack the model.
Mm-hmm.
So I think originally there were also some worries that if we show this, could this be misused? I think these days maybe this is less of a worry and there's more of an aesthetic worry that it's just super long and not very readable. And not
There was a
that
worry
useful.
on a certain point when the reasoning models came out to the public, where what the model thought could be offensive at certain point, and then that there was to have some kind of filtering. That some thoughts, everyone has dark thoughts sometimes, I guess. So I assume the models as well, and then that there was like no need for that to reach the public. So there was some filtering there, but there was a lot of like doubts of what were the reasons.
Yeah, so
behind
there was some decision to show more of the summaries rather than the unfiltered chain of thought. Yeah, I don't have strong opinions
Yeah.
about.
How do you feel when like people like Gary Marcus, they just trying to, I don't know, to a certain point it looks like they are trying to trash everything. We had a podcast with Ramon Lopez de Mantaras, which is basically in a very similar opinion to Gary Marcus. This got almost 1,100,000 views or something in this channel. It's the most viewed video of this channel. And basically he says this is all a bluff. You guys are like lying in most of the demos, like that. Basically, this is not really having any impact, and it will not go any beyond of being just like an answering machine. This reminds me a lot of these declarations when the internet came, that Nobel Prize in Economy said the internet will not have any more impact than the facts. So to me, it looks like that. But for you guys, it must get certainly almost personal when you're making all your efforts on this work, and then Gary Marcus says like, this is a piece of crap.
I think we're way too busy to follow it. So sorry. No, it certainly does not affect us. It's, but people should be skeptical. I think to be skeptical about the technology as a researcher, I just know it's misplaced. The technology is doing quite well, but we should be very skeptical about how we use it. Like, to use AI well, we'll need for everyone to adapt, and the technology will not adapt on its own. I mean, it's weird because it's the first technology that actually could, tell me, use me this way, and it may even be right. Who knows? But I think we need to take the responsibility as a society. How do we use it? And there's certainly ways to use it wrong. So that's a challenge where I would also be skeptical. Like, we try not to put ads in it is like one thing we can do, but how do we use this technology in our lives is a challenge. And I think these economists, I think for decades internet did not show in productivity statistics. So I don't think we should expect AI to like miraculously transform our lives into a paradise, right? I'm not that optimistic. But then, it can help you a lot. Like, even the advice, just go to the gym, and it just tells you twice a week, can help a lot. It's like small things, they add up. But for these small, like, I think the AI as tech, it will do more and more tasks of our jobs. It will, self-driving cars are there. They'll spread to more cities. Like, the technology will keep improving. I do think it's actually great. But for all of these improvements to actually translate into better lives for everyone, that the tech companies can't do this. This is something the society needs to do. And it's hard because we don't even know where the tech is going. Researchers don't know. Sam Altman doesn't really know. Nobody knows. Neither does Dario. I think we need to face this. That will it keep improving? Yes. But we still need to use it well, the way it is. And whether we'll manage to get the benefits for real, well, that is something where some skepticism is warranted, because it's hard. We got social media, and social media can be a very good technology. It could be used to inform people, it could be used for learning, it could be used in many good ways, and yet it feels we did not use it in the good ways, right? And we're not that much smarter now. So AI can also certainly be used in wrong ways, and we need to put some effort into trying to not make this happen. So this is where I think skepticism is very warranted. Because if you think of this this is almost like a technology from heaven that will fix everything, then you don't feel the responsibility that, no, you actually need to figure out how to make it work for you in your life. No one will come and tell you. Well, maybe your friends will figure this out so they can tell you, but it's not like OpenAI will come and say, look, you use chat like that and your life will become better. No, this is not that simple. This is a technology, a tool. It can do a lot of things, but you need to figure out what it can do for you, because we don't even understand it well enough to guide it. And then, in companies, it means the management needs to figure out. A lot of companies started, for example, blocking ChatGPT, and people use it on the side, and that's not good, right? This is not how to do it. At school, of course, I never thought about it before, but in hindsight, it seems so obvious that chat can just do your homework, and kids and teenagers will use it like this, and that breaks the system of homework. So that's bad, right? That we introduced now age verification, so that could help a little bit, but that's a big change. And how do we deal with this, right? Of course, you can try to do more work at school, but there is never enough time. So I think totally inadvertently it put teachers in the harder position. And so there are things like that, and we don't have the answer how to deal with it. Sure, we can put age verification and block some people, but you understand, this will not
fix the problem.
Some things became possible, and you cannot make them impossible. There also, if you don't use chat, there are open source models. There's Meta. The cat's out of the bag. If there is something that we thought was impossible, and now you have an example that it's possible, the technology spreads. It is possible, which means people will start doing it. But we need to find smart ways to use it and to deal with the problems. And of course, I hope that we can do this. And I think if you look at history, eventually this hope is probably right. But in the meantime, as we're going through these transitions, and as the technology is improving, there becomes more and more of these things every year. This is disruptive to people's lives in some ways, and how do we handle this well is a big question, right? It's can we in a short time find really good ways to use it and to block all the negative things? I hope we can do it better than before, but it's a difficult thing that it's not just on the tech companies. And if someone tells me, I'm skeptical, it may actually bring a lot of disruption well before it brings the benefits, then I would have to say that is a possibility. You need to very carefully think about that.
Lucas, Thank you very much. It's been an absolutely pleasure to hear from the source. I really hope your optimism carries away and the benefits like overload the problems that AI may bring, and that we can actually fix these problems to take all the benefits without any of these problems being a big issue. Really, thank you for your time. It's been really amazing, and I learned a lot today, so thanks for that.
Thank you very much.